Hi guys, welcome to my channel called .NET Go. Our today's topic is what is logarithmic time complexity. So before start with this session, I strongly recommended you to please go and watch my previous session, which is all about like what is linear time complexity, and why I am suggesting this one is because in this session only, in later part when we will start with our practical knowledge, that time you have to have that knowledge that what is linear time complexity, even means at that time only you can compare that okay, what is linear time complexity and what is logarithmic and what is the differences between these two time complexity. Yeah, so what is logarithmic time complexity? Algorithms with this complexity makes computation amazingly fast. An algorithm is said to run in logarithmic time if its time execution is proportional to the logarithm of the input size. This means that instead of increasing the time it takes to perform each subsequent step, the time is decreased at a magnitude that is inversely proportional to the input n. So I understand that by this definition currently you don't understand anything that what is going on, but for now you can just understand that if you write it down an algorithm which calls that it is following algorithmic time complexity, that means your algorithm is is working much smarter and much faster. Why? Because you know your particular algorithm will uh, divide a big problem into you know uh, multiple sub problems, and then it will execute your uh, dedicated algorithm on each part, rather than it will start from the first point and it will execute every code on every element. Okay, rather than that, what it will do is it will just divide your big problem in some parts, and it will find out the correct part, and in that correct part only it will execute your algorithm. So that is why this particular time complexity is compute amazingly fast, and it works amazingly smarter also, comparing to other time complexity. So this time complexity is generally associated with algorithms that divide problems in half every time, which is concept known as divide and conquer. So I believe you guys must have heard this word before, that divide and conquer, like divide and rule. Okay, so what happened is, as I have told earlier also, like this type of algorithm, what it is doing is it will take your problem and it will divide your problem in multiple parts, and it will then find out the correct part, and then it will apply the rest of the algorithm on it to find out a correct output. Okay, and yeah, I have mention the steps also, that first step is they divide the given problem into sub problems of the same type, and then the second step is they recursively solve these sub problems, and then the third step is they appropriately combine the sub answers to answer the given problem. Means what exactly I have mentioned earlier, right? That it will take a big problem, then it will divide those problem into sub problems, then they will solve the rest of the algorithm. They will execute the rest of the algorithm, and then they will find out the correct answer. Okay, and the fourth point is it is denoted by big O notation, and inside the first bracket it is it has been log n, where the n is your input size, and log because it will take a time comparative to you know log n. That is why it is the name of this time complexity itself is a logarithmic time complexity. Okay. Okay, now here I'm having a small diagram, which this diagram is actually follows a graph structure. A graph means this is our y-axis and this is our x-axis. So this axis dedicated for input data size, okay, and this axis is dedicated for number of operations. And if you see this particular arrow, okay, this means is nothing but it is actually indicating that depending on these two axes, what is the result. So this is indicating your time complexity. You can see the notation also for that. Okay, apart from that, I'm having Visual Studio, and I have created one problem to make you understand from a practical knowledge also, that here the problem is I want to find out a number. That number I have mentioned here is 9. Okay, so for that I have created one integer array, and I have stored some integer in this particular array. So that integer starts from 1 and it's end with 14. So this total value is serialized. Okay, it starts with 1, then 2, then 3, 4, 5, 6, and then go on, and it end with 14. So what happened is I have created two different function for the same problem. I want to find out the number called 9. Okay, so the first function, it is by the name only you can understand that find the maximum number with linear TC, means time complexity. So that is why I am repeatedly telling you that please go and watch the previous session where I have explained that what is a linear time complexity, right? So I have called that particular function over here, and now when I have started this one, so what it will give is, it will give this type of output. In this type of output, you can see what it has written here. It has written like the loop has been ran for one time, then 2, then 3, 4, 5, 6, 7, 8, and finally when it's reach at the number of 9, then it is found the number 9 from that particular array. Okay, so basically what I am trying to say is that this particular algorithm which follows the linear time complexity, it has executed a for loop for 9 times to find out the correct result. Why it is ran the loop 9 times? Because if you see the code here, I have created the for loop, and here I am directly comparing each and every element with 9. That okay, if this element is equals to 9, no, then again it is executed the loop, and it is came to this element, and again I am comparing this element is equals to 9. It is again it founds that false, then again it is executed the loop, and it is reaching up to this point. Like that it is working. That is why it is performing that particular code on each and every element until unless it is reaching the correct output, right? But for the same problem, if you follow if you have created an algorithm which follows that logarithmic time complexity, then what will happen? We will find out. First of all, we will comment out this particular function, and we will uncomment this particular function which follows that logarithmic time complexity, right? Now when we start this one, so you can see here what it is saying is that the for loop has been ran for one time and then for two time. So basically in logarithmic time complexity, the loop has been executed for only two times, and after two times only it is find out the correct result. So how it is even possible, right? Because in logarithmic, what happened is I have created the same array, I have given the same value from 1 to 14, but here I have divided. First of all, I have take that length, array length, and then I have divided that array length into two parts. Okay, I have divided this problem into two parts. Now what happened is, after dividing this length, I have started, I directly compare the midpoint, the midpoint with my target number. So the midpoint is, if the length is 14, I have got 7 here. So 7 means 0 1 2 3 4 5 6 7. So I find out this element address, int array 7 index means I'll found this value. So I'll directly compare with the midpoint, that whether it is greater than 9 or it is smaller than 9. Okay, so I have write it down a a statement, a condition called whether it is a smaller than 9 or not. So if so 8 is definitely smaller than 9. Okay, so what happen is, it is directly uh, go go inside this particular if loop, and then it is start executing this for loop. Now I have write it down, I have created this for loop particularly based on this particular condition, that I am not starting this for loop from the first index, because I have found out that this index value is lesser than 9. Then the output should be between this, from this index to this index. So I will not even execute my for loop for all this index. I will not waste my time with these values. I directly start from this index, and then I'll execute my for loop. So here 9 is the second index, that is why it is executing our for loop two times only. Okay, clear? So that's it from up to this point and for this session. Thank you very much for watching this video. I hope you have understood that what I want to convey to you, that what is logarithmic time complexity. And this logarithmic time complexity is the second fastest time complexity after the constant time complexity. So hope you have enjoy this video, you have understood and you have liked this video. Please share this video and like this video and subscribe my channel. Thank you.